Can you tell us, what did you say grassland soils were called?
Mollisols.
How do you spell that?
M-O-L-L-I-S-O-L-S. Mollisols. You can actually, I can go into more detail about it later. If you have questions. So this is, so to find more information about, did I skip this line? Okay. So to find more information about your specific soil at your house, and sort of the chemical properties and the physical properties, there is a website that is run by the Natural Resource Conservation Service, which is part of the USDA. So I'm going to show you guys this. I don't like to spend a lot of time just like clicking around websites during a presentation.
Well, while you're clicking, I've got a question.
Shoot.
You're showing us subdivisions, and I don't know about the Livermore Valley. Maybe it is the valley soil you get there, but subdivisions I've lived in over the years have been soil that was brought in and, brought in with heavy machinery. But does that still tend to be representative of the area because they wouldn't have brought it from very far away?
In general, I mean, I have some very sandy stuff in my garden that was filled, that was brought in, which is on top of what is otherwise a clay loam. So if you know that what you have is fill, this is probably not going to be representative. What's actually really, so let me scroll down here. So NRCS has this thing called Web Soil Survey, and if you go to their homepage, it's going to look like this, and you're going to have to start Web Soil Survey, and it's a very clunky government issue software, and you just have to deal with it. You have to, they have all sorts of help pages to help you run this program that accesses a database that has information on every soil in every soil survey they've ever done in this country. And so it's really powerful, and there's a lot of information there, but you have to just be patient with it. And so what I've done here is I've just pulled up a tab, and I defined my area of interest, because that's what they have you do. You mark off a square that you're interested in, and then you can go to this tab here that says Soil Map, and it will give you a soil map. Now it's hard to see here over all of the subdivisions, but there's actually a square that I've pulled up here. Put this down. There's a square that I've pulled up here. You can see it here. It's blue. And then inside of this square, it actually has marked off these orange divisions here. These orange lines between the spaces. This one says LG. This one says ZA. And what those show are soil, they're called soil map units. And this is before, what you can actually see in the Livermore one is they did a soil survey at one time when Livermore was small, so downtown is way over here, and they didn't survey downtown because there were houses on it, but they surveyed the rest of Livermore because there were no houses here. And so these are old map units that they did a long time ago. And so you can pull up information about your soil. So we at Garden of Grace are right, I can never go from Almond Circle, yeah, here. So we're here, and so this is PGA, is the symbol that they have, and then we can go down here, PGA, Pleasanton Gravelly Loam, 0 to 3% slopes. And then you can actually pull up a whole bunch of information about Pleasanton Gravelly Loam. So it's pretty cool. And then the other thing that these guys have done recently, and it might be a lot easier, you have to kind of, I haven't, so it's not on this page, but the other thing that NRCS has come out with recently is they actually have an iPhone app, which is a little easier to use than what I just showed you. You can download it to your iPhone and it will tell you what map unit you're on by just using the GPS on your iPhone. You can just stand there. So it's really cool. It's really powerful. It tells you a lot about the particle size and all sorts of, and the origin of your soil and the name of your soil and all that kind of stuff. So that is cool.
That also works on your iPad.
It works on your iPad too? Have you done it?
Yes.
Sweet.
Oh.
So what does all this that I've gone over so far mean for Alameda County soils? What can we say about them? So soil is complex, so it's hard to make generalizations. I can't really speak to your soil because I don't know everything about the climate, topography, time, and biology of your soil. And it's hard to, even if I knew all of those things, it would still be hard to make predictions about what exactly is going on with your soil. So Alameda County, but I can say some things. Alameda County soils usually come from either Franciscan or Great Valley Series parent material, which means the Coast Range hills are made out of this stuff that they call gray-wacky sandstone, which is this sandstone that has a lot of volcanics in it, and it's really erodible. If any of you live on a slope that's failing, you will know that. And it tends to weather to clays. It actually tends to weather to really high shrink swell clay. So that's one of the reasons why we have a ton of clay, a lot of clay here. The climate is Mediterranean. What that means is that it's hot in the summer and rainy in the winter, and the temperatures are kind of moderate, and it's really a very good environment for microorganisms. So we tend to have, because it's favorable climate-wise for microorganisms, they're eating all year round. It's not like places where it gets freezing cold in the winter and the microorganisms stop eating, which means that they oxidize off they eat up a lot of our organic material. A lot of times you will hear that soil should be about 5% organic matter. In California, it's really more like 1 to 2% is a normal number for the amount of organic matter in a soil, in a sort of natural ecosystem. Topography obviously varies a lot. Keep in mind that the biology that you see on top of your soil now, especially if you're gardening on it, is really different than what it would have been when the soil was forming. For example, I think a lot of Livermore was kind of, when you see a lot of clays in the soil, a lot of times it's sort of vernal pool habitat, because those clays, they tend to just keep pools of water around. A lot of places in California were oak woodland. A lot of places in Alameda County were, like in the Oakland Hills, were redwood forests. So the soil, the conditions that created your soil are no longer there. And then our soils are young. They're very young geologically, which is a very good thing because, if you lived in Appalachia, a lot of the mineral nutrients that are in our soils here, in places like Appalachia that have really old soils, all of those mineral nutrients have weathered out, and it's much more difficult to grow things.
When I used to live in Livermore, I don't any longer, but my soil here was very gravelly. I don't know if that.
That's from the alluvial parent material. When mountains erode, what happens is the biggest chunks, the boulders, are deposited really close to the creeks, and then finer and finer material is deposited as you move out away from the creeks. And Livermore, I think, just because it's close to the hills, stuff just washed in, washed in, and kind of the history of that would be that there would be creeks that came out of the hills, and they would kind of move back and forth across these alluvial fans coming out of the mountain. So if you see gravel that was deposited in a stream bed, it means that your place was a stream bed at one time. Okay, so we're going to look a little bit closer at a cubic centimeter of soil and look at pores and solids. So we're looking real close now. Coarse textured soils can have as much as 70% pore space by volume, so that cubic centimeter of soil is mostly air. Fine textured soils can be as little as 20% pore space or less if they're compacted. 50% is kind of a quote-unquote normal number. There's nothing normal for soil really though. So pore spaces can contain gas or liquid. So we're going to look closer at soil gas. Soil gas is higher in CO2 than atmospheric gas because of respiration. So those microorganisms are just like you and me. They eat carbon, they breathe out CO2. The relative humidity in soil is almost always 99 to 100%. You have to bake it in an oven to get the humidity, to get the water out of it. And then just a fun fact about soil gas, the smell of rain is really the smell of soil gas that escapes from soil pores as it's being displaced by water in a rainstorm. I had this amazing experience on an elementary school field. I was teaching a group of kids and this big kind of squall line came in and you could feel it pushing the soil gas out as we were running away. Soil water. So soil water can also fill up the pore spaces. It includes dissolved anions and cations. I didn't put the chemical formulas up there because I think a lot of people get weird when you put chemical formulas. I don't want to give anybody the squicks. But a lot of these are mineral nutrients of plants: calcium, magnesium, potassium. These are all positively charged ions. And then also some negatively charged ions are found in the soil solution. The anions are easily leached into the aquifers because they're not trapped by soil and organic matter particles. So just keep that in mind. Organic matter and clay particles can be suspended in soil and water and moved down through the soil profile. That's what we were talking about in soil formation. The clays and some of the organic matters leach down, and that's what causes the soils to start to form in layers. The soil solution can vary a lot in its composition depending on the time of year. So, for example, the soil solution contains a lot more salt in the summer. The reason for that is because as the soil solution evaporates, a lot of times things like carbonates come to the surface. You get a rainy year and the soils will actually test lower in carbonates and salts because a lot of that stuff has been washed down in the profile. Any questions about that? I hope I'm being clear. The other thing that's really interesting is nitrate concentration rises in the spring because that's when soils are warm and damp and it favors sort of bacterial activity, microbial activity, and you get a lot of mineralization of nitrate and nitrification too. So we'll talk more about that in a minute. But that's when, when I worked on a farm and we would get our well tested, the nitrate numbers would go crazy in the spring. So now we're going to look at solids and talk about the mineral and organic parts of the soil. So the mineral fraction is composed of all of the inorganic particles. So that means like the kind of silicon-based stuff, not the stuff that was once alive, the stuff that started out dead. So the particle sizes of those mineral particles are classed into sand, silt, and clay, so we'll talk about that. The local soils are mostly composed of silicate mineral particles. There are soils out there that have a lot of oxide material, so like soils that are basically made of rust and or aluminum oxides, but those are all really, really old soils, and we don't have those here. They're found in the tropics in general. I have a clicker. So, and then clay minerals are the most chemically active in the soil.